Today's RIMS webinar, sponsored by Global Risk Consultants, a TÜV-sued company, predictive strategies to detect electrical and machinery failures. I am Justin Smollison, Business Content Manager here at RIMS, the Risk and Insurance Management Society. A few notes before we get started. If you have a question for the presenters during today's session, please submit them by writing in the question box. The GRC team will reply to you directly after this session if we can't address your questions today. And following this session, the recording will be available through the on-demand events page of rims.org, and all downloads and contact information will be accessible to the sponsor. And on with today's presentation, with risks ranging from extensive property damage to significant business interruptions, risk managers face high stakes in identifying and mitigating electrical hazards. This session will provide actionable insights and tools to reinforce your risk strategy and drive better outcomes. RIMS is thrilled to welcome a large global audience, and now I will hand it off to our moderator, GRC Marketing Manager and my friend, Jared Shelley.
Great, thanks, Justin, and hi, everybody. Welcome to today's webinar. Every business must protect against fires and mechanical risks. That starts with electrical hazards. In fact, electrical hazards are among the top 3 leading causes of fires at industrial and manufacturing facilities. Between 2017 and 2021, U.S. fire departments responded to an average of 8,077 structure fires at industrial or manufacturing properties each year, causing 155 civilian injuries and 988 million in direct property damage. From 2013 to 2022, there has been an 8% increase in financial losses from electrical malfunctions. The stakes are high for risk managers and company leaders. A significant loss can lead to property damage and costly business interruption. But there are plenty of predictive and preventative strategies you can implement to stay protected. Today's speakers are experts in these topics and more. Lee Bowers is Vice President of Environmental Health and Safety at RPM International, a world leader in specialty coatings and sealants. He is responsible for the company's environmental compliance and stewardship efforts at all global operations, instilling a culture of continuous improvement in its health and safety programs to protect RPM employees. He previously served as head of operations for RPM's Performance Coatings Group and was an adjunct professor at St. Joseph's University. Craig Bartle is Executive Director of Risk Management at Johnson Controls International, which offers a wide range of building technology, including HVAC, fire, and security equipment. Craig is responsible for the company's overall risk management strategy and insurance programs. He previously served as Global Risk Manager at Nike and Director of Risk Management at AT&T. Jeff Freilich is head of electrical protection services at GRC, a new division encompassing infrared, arc flash, and electrical safety training. Jeff is our resident whiz on all these topics and more. He has spent 36 years in risk engineering, helping businesses in heavy machinery, manufacturing, power generation, food and grain, and many other industries identify hazards and reduce risks. Thank you all for being here today. It really means a lot. So in today's conversation, we will discuss why predictive and preventative electrical maintenance is critical, top issues risk managers face regarding electrical protection, how robust predictive and preventative electrical maintenance programs impact insurance, real-life case studies showcasing how infrared thermography and arc flash analysis detect serious hazards, and why it's best to bundle infrared thermography, arc flash analysis, and electrical safety training. I'll conduct today's webinar interview style, asking questions to our panelists. If you have a question, please put it in the question box on your screen and we'll answer it at the end of our session. We really want this to be interactive, so get those questions in. So now to my first question. We'll start here with Jeff. Can you describe the importance of developing predictive strategies to detect electrical, mechanical, and machinery failures?
Thank you, Jared. It's great to be here. Looking at predictive and preventive maintenance strategies, I've listed 9 of them here. There's a host of wide range within the industry, but these are some of the keys: infrared thermography, looking for all kinds of abnormal heat signatures, motor circuit current analysis, arc flash studies, oil analysis for transformers and lubrications, things like using a 5-part liquid screen, dissolved gas, oil, and analysis to check for the condition and health of the oil. Looking at ultrasonic, airborne ultrasound studies, there's two-prong. There's standard airborne ultrasound acoustic analysis and partial discharge studies. One will focus on listening for sounds that might be indicative of different electrical components that are faulting, such as loose connections, arcing, or poor insulation. The other, partial discharge, may use more specific types of equipment to check for electrical signals in medium or high voltage, which may be indicative of localized breakdown in insulation. Vibration analysis, switchgear maintenance. That'll come with a whole host of electrical exercising and functional tests of your switchgear components, and pressure monitoring, things in the sensors, early warning symptoms within machinery, industrial pipeline, hydraulic systems, things of that nature. As we break down into the various other categories, electrical systems, we've got numerous standards around the world that will provide frequencies and intervals for each of your electrical system components. Mechanical integrity systems, things like lubrication checks, applications for bearings, gears, chains, sheaves, things of that nature. We have fluid systems, things that'll get involved with your oil, your coolants, hydraulic fluids, perhaps filter replacements, contamination checks. There will also be operational monitoring, where you may be listening for unusual noises or vibration in your equipment, monitoring temperature readings on critical assets, possibly checking for abnormal pressure or flow rates. Of course, we have our electrical safety standards and regulations compliance. Individuals like the gentleman here on this presentation, and all of you EH&S and facilities maintenance persons have to comply with the various international standards, NFPA, IEEE, ASME, and others. Structural components, visual inspection, cracks, corrosion, deformations, a whole host of various elements in the welding integrity, and then safety systems, functional checks on your safety equipment, machine guarding, checks on your interlocks. If those interlocks aren't functioning properly, it could result in a significant safety issue. So those all need to be checked and tested. And things like emergency stops, e-stops, they need to be functioning and performing as designed per the manufacturers.
Great. Thanks, Jeff. Appreciate that response. Let's go to Lee here. Lee, what is the importance of electrical predictive and preventative maintenance programs like IR, arc flash, others, in mitigating the risk of serious electrical issues, and how do you incorporate them into your strategy?
Thanks, Jared. Sure. In addition to the code compliance with NFPA 70E, conducting initial arc flash studies across RPM's facilities and even conducting the 5-year revalidations ensures that our operations don't have overloaded electrical devices, and helps our management teams identify the appropriate PPE required for employees and any contractors working in our facility, to make sure that they've got the right safety measures in place prior to starting any of that electrical infrastructure work, or any kind of maintenance activity.
Great, thank you. And then let's go to Craig too and get your opinion. What are your company's top goals with regard to electrical system protection, arc flash, and electrical safety?
Yeah, thanks, Jared. So I think it would be threefold. First is to ensure the health and safety of the roughly 100,000 employees Johnson Controls has around the world. The second, like for many of or all of us, it's regulatory compliance, which are table stakes. And then the third is to minimize the impact of downtime so we can continue to meet our customer commitments in either manufacturing and delivering product or servicing that product anywhere around the world.
Great, thanks, Craig. And Lee, let's go back to you. What are the main issues you face with regard to electrical hazards in your manufacturing and warehousing facilities?
Sure, sure. For RPM and our operating companies, it's aging electrical infrastructure at several of our older facilities globally. And in some cases, historically, a lack of adequate maintenance being conducted on those electrical devices in those sites and on the electrical distribution systems. So we're playing a bit of catch up. We've got over 400 sites globally, and several of them are aging. So we partnered with GRC several years ago, and we're working through it and improving each site, one at a time.
And then, Craig, same question to you. What are the main issues you face with electrical hazards?
Yeah, so similar to Lee at scale, we have owned or leased locations.
Craig, are you there?
He may just have a little bit of a slight interruption there. You might need to
Looks like
ask someone else to
froze
weigh in,
up.
or give
I
him
was
a
wondering if
moment.
he was nervous.
No, I don't think
it's a technical thing.
he doesn't seem like a nervous
Looks like
type
it's
guy.
frozen.
No, not at all.
Yeah.
We can go.
I can jump in on his
Sure.
piece, and certainly having conducted surveys for his facilities around the world. Various plants spread across the world. His facilities are built and expanded over the decades. Oh, there he is.
Hey, Craig, you must have got locked up there. That's okay.
We'll have you come back in.
Sure. So I'll just repeat. I'm not sure where I
Perfect.
dropped, but similar to Lee, I have owned or leased locations in 62 countries around the world, many of which were acquired during acquisitions. Much of our manufacturing footprint continues to evolve and be expanded upon. And then we have ongoing training obligations for both our employees at the manufacturing plant level and our employees that go out and service customer locations anywhere around the world.
Great, thanks, Craig.
I'm going to jump in on this
Yeah.
one too, Jared. Anecdotal. Certainly on board with both of these gentlemen. Indeed, in the process of conducting our inspections around the world, we find that a significant portion, and we'll see later in the presentation, kind of a breakdown of the different fault causes. But on average, we're finding somewhere in the range of 45 to 65%, could be even significantly higher on an individual facility by facility basis versus the stats here on an average aggregate basis. Loose deteriorated connections tend to be the most significant frequency issue identified in these infrared thermographic studies, and frankly within electrical system failures, a significantly higher percentage is due to some form of deteriorated connection. Secondly, contaminants. Lee mentioned it. It's a significant issue depending upon the type of occupancy. And regardless if you're just a straight metal worker, a dry manufacturing shop, there's going to be opportunities for airborne contaminants, whether it's dust, debris, wood, sawdust, metal shavings, all kinds of different elements. You can see in this photo on the slide, there's about an inch thick film of cardboard fines in a specific type of operation. In the woodworking and in the food and grain standard industrial classification codes, you're going to find a lot of contaminants, and those will wreak havoc on electrical connections, as well as the third point is overloading, imbalanced, and deteriorated insulations will account for up to 25% of the anomalies identified in an electrical system scenario. So 3 key elements that make up a significant portion of the anomalies within industrial and non-industrial operations.
Absolutely. Thank you, Jeff. And Craig, let's start with you on this question. So how does electrical predictive and preventative maintenance inspections and programs impact how you buy insurance and work with underwriters?
Sure, Jared. So the status of our electrical risk control program, like infrared thermography provided by GRC around the world, is a discussion point with our insurers to demonstrate the actions we take to reduce the potential for loss. It's a component of demonstrating our commitment to the highly protected risk standard. And also internally, it helps me allocate expenses for these insurance programs down to the facility level. So those facilities that have a better score or take more proactive measures see a better allocation than those who might not.
Sure. And Lee, same question to you about how this whole thing works with impacts how you buy insurance and work with underwriters.
Absolutely. Yeah. So, since 2018, RPM's transformed our manufacturing footprint globally through strategic facility consolidation and expansion. What comes with that is over those 6 years, significant impact to our electrical infrastructure in nearly 20% of our facilities from those changes and expansion, and many of which these sites are outside the US. Like Craig, for RPM, our reinstatement of what we call a center-led electrical safety program with GRC demonstrates our commitment to the insurance carriers and brokers of maintaining a robust electrical safety program globally, while also accounting for an unprecedented amount of change within our organization that impacts those operational assets.
Absolutely.
Jerry, if I can jump in on this one, I think there's another good point to bring to light. Clearly, the insurance world is intimately concerned about adequate protection of facilities. So many of them will have standards and recommendations to perform predictive and preventive maintenance. One of those primary elements that they're all going to hone in on will be infrared thermography surveys. So they're requiring it on behalf of their customers and on behalf of just best practices. So it's definitely an element in the checkpoints that they will do in the course of their risk engineering inspections and consultations with their clients. So it's being driven also within that community and across the world.
For sure. So now let's talk about infrared thermography. Let's get into the specific ways risk managers and property risk engineers can identify and mitigate electrical fire and machinery breakdown. And that sort of starts with infrared thermography. Jeff, can you explain infrared thermography and the causal factors, predictive forecasting, and discuss potential failure? And I know we have a couple slides here, Jeff. So when you're done one, just tell me, hey, next slide, and I'll just advance the slide deck. Okay.
Absolutely. Thank you, Jared. Great, excellent. Infrared thermography, something I'm really passionate about. It's such an impressive and awesome technology, especially today. You see the graphic photos and look at how the technology has evolved over time from the simple DIY spot radiometer you pick up at a Lowe's Home Depot, which has a very wide range accuracy, mind you, relatively low, to the professional grade series cameras that are going for $30,000+, plus all the accessories and the sophisticated instrumentation, the onboard computing. So it's quite the impressive place to be in today's world. But simply speaking, it's a non-destructive technology. And what does that mean? It'll examine the properties and integrity of your structure, material, component without causing damage or destruction. It's done live and energized, and you must have line of sight. So don't be fooled that if you have an infrared inspection done, yep, we're all good to go, a survey was done. You might have a lot of equipment that couldn't be opened due to arc flash, something we'll talk about here in a few minutes, or due to an interlocked machine, or due to conditions beyond control. And so it's important. You might have a visual arc flash plastic Lexan shield that when you open up the control cabinet will be present for arc flash protection, part of the manufacturer's optional ads. And while you can see through it, the infrared technology cannot scan through it. I always like to use the expression, it's like kryptonite to Superman. So you have to have a line of sight. So there are some techniques and options, solutions to provide in order to be able to either scan them safely, de-energize, and go through a safe method for the scanning and then re-energize, or look at other alternatives. But it's a non-contact technique. It'll measure temperature differential. So there's a lot of things to record and observe in the thermography. Spot maximum temperature is one thing. Depending upon where you are around the world, wires will have different temperature ratings. And so, what might be acceptable threshold for a certain component or a certain asset might not be in a different country, or might not be for a particular type of component. So there's a whole slew of things to consider in that regard. There's also temperature rise, and the delta is which becomes the most important, typically underlying element. So we're looking at the reference temperature within that circuit, and we're taking the maximum temperature subtracted, that reference temperature subtracted from the maximum temperature. So it's important that we are assessing what the differential is. And then different objects will have a different surface temperature. It's actually picking up surface temperature, depending upon what the emissive qualities of that object are. Something that's very shiny is going to have a very low emissivity, and so your accuracy is going to be much different versus something that's very high emissive target. So we're looking at state-of-the-art thermal imagers. They'll convert the energy that's being recorded into a temperature map, and it's displayed on the screen, as you can kind of see above, as an image. And some of the major goals are, of course, locating those abnormal heat signatures, or in some cases, a cold object might be problematic. There may be some circulation issue in an oil cooling system for, say, like a transformer. So we're going to determine a wide range of different types of anomalies. It's basically used in every sector of industry today. And it used to be primarily an industrial manufacturing tool and service for primarily those high challenge environments. Companies in the power gen, the mining, pulp and paper, construction, cement, sawmills, high amperage, high loaded. But now we're finding it used throughout in non-manufacturing, commercial, medical, corporate office buildings, light hazard risks, and of course, we've got firefighting and law enforcement, different applications. Next slide, Jared. Here we show the potential failure curve, also known as the PF curve. Three major domains: proactive, predictive, protective. So your equipment, brand new, it's going along over the course of the years. It's functioning great, performing extremely well. At some point in the lifespan or the life expectancy of that equipment, you'll begin to notice potentially early on the far left a visual identification, potentially even a design flaw right out of the gate. During commissioning, you find either through a visual or some type of predictive measure some type of an anomaly. Hopefully you can fix and repair or replace that early in the game, but it typically doesn't happen. And then you move through the chain of predictive types of studies. And some of the first items up in the detection capabilities are these airborne ultrasounds, where you're listening for these acoustic emissions, things that you may not be able to hear with your standard hearing ranges. Then you might get into changes in vibration, molecular disturbances, wear, debris in the oil. So there's, contaminants in the oil. And pretty soon thermography will be able to detect some of those anomalies that are generating heat. It may not occur where there's a heat signature, and you may see something occurring that would be in one of the other categories. At some point, once you get into the, so you're in that predictive domain up until that point. And then when you move beyond that, if you aren't doing thermography or aren't repairing those anomalies, those faults that have been identified, you start to move into the phase of audible noise. And now you're in the protective domain, you're getting closer and closer to failure. Depending upon temperature, the likelihood might more likely than not increase in the potential time frame where that's going to fail. It might be a couple of hours to a couple of days to a month, who knows? And it can go either way, even on a lower temperature gradient. Electricity works its wonders in many different ways. But once eventually you get hot to the touch, you're in a potential immediate imminent danger situation, and you get to eventual failure, at which point you may be talking electrical incidents, which will be a significant energy of an arc flash, or mechanical, where you have a seize up of a bearing and a machine that's going to abruptly stop. So I've included several of these different predictive preventive maintenance type programs up in the upper right. And another key point is all of these elements, if you're doing your predictive and preventive maintenance, will have an energy savings, a conservation component. So it's extremely high return on your investment. Next slide, Jared. Here I've got the bathtub reliability curve shown. You can see that depending upon what type of equipment you're looking at, transformers, breakers, motor control centers, variable frequency drives, motors of a smaller horsepower rating up to more significant horsepower ratings, UPS, uninterruptible power supplies, capacitors, and a whole slew of things. They all have a lifespan, similar to your appliances that you get for your house. And you can see the various expected useful years in life. What we're trying to do with these predictive strategies is stretch the life of your equipment, diagnosing them early, because you're going to eventually find faults and abnormalities throughout the course of time within that 10, 15, 20 plus year lifespan, due to the environmental factors and all the other elements that happen in an industrial or a non-industrial occupancy. So at the early stage of original installation, you have to be concerned with workmanship, contamination. You'll have a burn-in period, your quality control program. As you then move through that middle phase where it says steady state, you may have some random failures. Lee mentioned earlier, overloaded circuits and things of that nature. Imbalanced circuits, different extraneous forces coming in at the utility services with different types of power that will be provided or supplied. Improper usage of your equipment, or loading on your equipment. It was added on over the course of the years, and now it's being taxed more heavily. You get into the wear out period, and that goal is to kind of stretch that life so that you can repair or replace it in time, aged equipment, potentially obsolete equipment. And then in that wear out period, you could have things like thermal fatigue, oxidation, cracking, spalling, shrinkage, frictional wear, and things of that nature. In terms of doing your predictive preventive maintenance, using a good, robust infrared thermography program coupled with all those other PDM programs in accordance with the frequencies recommended by the international standards will help to increase the curve and the life of your assets. Next slide, Jared. This one's a great slide. It is one that was compiled through the excellence of the insurance industry that keeps data on losses, that they're encountering with their insureds. So we have many carriers out there that are capturing how are these losses that are causing fires and property damage around the world playing out in terms of electrical failures by fault causes. So historically, as I mentioned earlier, loose connections, also known as high resistance HRC connections, are the most significant frequency item, and it's detectable with infrared. And it's shown on average aggregate 30%. It's typically a lot higher, but aggregate wise around the globe, different occupancies, different types of operations will have a different percentage of them. You'll see moisture detectable, also either visual, potentially infrared will show that based on different types of conditions or applications at approximately 17%. You've got line disturbance, that's not lightning. It's a detectable increase in resistance that's going to generate abnormal heat. Things like voltage sags, surges in high voltage. You may have some transients or harmonics that'll distort the waveforms in electrical systems, frequency variance, basically unwanted variation in voltage or a current and a frequency of your electrical power line that may be disrupted from your normal operations, and that'll cause problems with your electronic devices. So what you can do there is do some surge protection, UPS, or some line conditioners to help improve on mitigating that 11% in there. Defective or inadequate insulation is another key cause. It's really derived from physical damage, abrasions or cuts in your wires, aging or heat, moisture, rodents perhaps, something as simple as that. So keeping your panels in check, and then possibly manufacturing defects. Signs or symptoms might be fraying or cracking, peeling, discoloration, exposed wires, things of that nature. Foreign objects and short circuits count for about 7%. A lot of causes of that are going to be loose or faulty wiring, ground faults, or overloaded conditions. Moisture will generate overheating or sparks, a blown fuse, things of that nature. Collision, physical damages, smaller. And then, of course, the contaminants tends to be much higher than the 2%. All of these things mostly are detectable. Of course, certain things you never can predict where lightning's going to strike. So at 8%, that's a pretty big wild card. But let's go ahead with the next slide.
Great, thank you, Jeff. Very thorough response. Really appreciate that. And now we'll get to the sort of the fun stuff here. Can you provide a few case studies of infrared thermography in action?
Excellent. Yes. Hard to choose which ones, but we've got a couple of good ones here. This one's a 115 kV switch. That's 115,000 volts. It's at a large woodworking facility. It is at the incoming service on an overhead superstructure. It's also, interestingly, a coastal environment. So what we have is some additional extraneous factors, environmental conditions, things that such as seawater and salt-laden air from the ocean are going to bring in new and unusual conditions that will increase things like ozone and the potential for corona formation on the electrical systems. That will create all kinds of different anomalies, one of which could be partial discharge, we mentioned earlier, things that we can pick up with ultrasonic signals and tools and equipment. Of course, thermography is a key item. And these things can lead to power losses. They can lead to cable degradation. High humidity will enhance this potential. Mitigating would be making sure you're using specialized insulation, larger conductors, things of that nature, proper cleaning and maintenance. We're showing an 85° C delta. So this one's a significant showstopper. Shuts down the whole operation. Could be $1 million a day. Depends on how much product they're producing, but it's a big one. And the lead time could be catastrophic. You're talking a switch that might take you 1 to 4 months. Perhaps the utility's got something, they're going to come and, get this company back in business as fast and as quickly as possible. But if it's a different type of a scenario on a transformer that blows up, it might be something like an 18, 24-month lead time. You could be out of business. It's a significant deal. Next one.
Brutal. The stakes are high. Go ahead, Jeff.
Yeah, absolutely. So here we've got a significant primary piece of switchgear. It's 480 volts, so it's classic 3-phase, 600 amp switchgear. It's big time operation here, and you've got situation here where you have, once again, a high resistance connection. It's formed from a poor or loose contact between conductors. In this case, we've got different potential for contaminants or dissimilar metals. And it could be as simple as improper tightening. When they install, it's important that you're looking at the right torque spec, the right type of bolt and washer. They all have to be similar and compatible. And if you don't, you can have induction heating. You can have a gapping situation, and using a calibrated torque wrench and other types of techniques are crucial to making sure that the equipment is going to be properly maintained and will receive good contact. The consequences are significant. You'll have heat generation, damage for wiring and bus. Resistance will restrict the current flow. You'll have a major potential for an arc flash condition, an unexpected and uninterrupted or unplanned outage. In this case, this is probably one of the highest I've seen in my career, significant at a maximum temp of 688 degrees C. That's over 1200 degrees Fahrenheit. So you're at imminent failure. I'm surprised this thing hasn't already, but it just goes to show you significant. This went into emergency shutdown, and they were able to correct and repair it prior to. It's probably one of those where you can't open it due to production cycles and other factors, but certainly advanced planning and taking it down before an unplanned outage was key. Next
Let's
slide.
do one more.
Okay, we'll do one more. We've got the environmental factors again coming at you, especially in thermography. We have to account for all different types of things. We talk about different targets will emit at a different level percentage. So it's important that you're capturing all of those techniques. That's done through good quality training with recognized leaders in the industry that provide the certifications for infrared thermography. In this situation, you've got a left and a right scenario where you're potentially going to have wind effect, and the wind effect will play a key role in what are the actual temperatures recorded on the bushings in this situation. So the wind effect can significantly reduce those temperatures. You see on the left 85, 76, 72, but with a wind, without that wind, you're talking about a much significant jump, 117, 95, 81 Fahrenheit in this case. And general rules of thumb, 10-mile-an-hour wind, reduction of about 50% in the delta. That's the temperature rise I was mentioning, versus a 15-mile-an-hour wind, a reduction of potentially up to 67%. So a significant factor have to be considered, because you might overlook something if you're just going straight in without a wind effect consideration.
That's a great one, Jeff. Thank you. And Craig, let's go to you for the next question. So what impact does infrared thermography have on your risk profile and portfolio of your global operation?
Yeah, thanks, Jared. So it certainly improves our risk profile. It helps us identify areas which could lead to a loss. This in turn helps us reduce the frequency to loss once what's been identified has been corrected. At some of our manufacturing locations, GRC may look at 1,000 or more objects. So the infrared service is viewed as extremely valuable by our local operations teams. While all the reports from GRC come to me in English, the reports go to my local operation teams in local language. So that helps eliminate any risk due to, English to local language translation. And then anecdotally, many, many years ago, at a former employer, I was part of a project team that built a large distribution center in China. We had issues optimizing the conveyor system that moved the inventory around. We brought in the GRC team who shot the conveyor system, and they were able to identify problem areas, which then the conveyor vendor were able to eliminate, enhance, and optimize the system.
That's great. No, I appreciate that, Craig. And Lee, same question to you. Can you explain how infrared thermography has sort of impacted your portfolio?
Yeah, sure, Jared. Frankly, the IR scan program, at RPM and our operating companies that we've put together with GRC, it serves as our first line of defense for the facilities to detect potentially hazardous anomalies, like Jeff was just describing, throughout our electrical distribution systems, motorized equipment, and any other powered equipment in our manufacturing or distribution operations. With an aging electrical infrastructure at more than 20% of our facilities, this is especially important part of our electrical safety program and has now become one of our 6 center-led EH&S service program. What that means is it has the same level of oversight and corporate visibility as our various corporate-led EH&S audit programs on a global basis. And that means, everything from scheduling, the frequency, and the follow through on the findings from those IR scans at those sites is being managed from the top down in the organization.
Great, thank you, Lee. And let's move to arc flash analysis. Jeff, can you please explain arc flash analysis, what it includes, and the key benefits?
Sure, Jared. Thank you. So we kind of have it broken into 5 phases, if you will. There's many interstitial elements within each of the phases, but on a general basis, we have the first element or first segment of it is data collections, where the field engineers are going to go out and collect a wide range of data on the electrical system necessary in order to complete the computer modeling. So they're going to start from the utility services, work their way down through the electrical system, collecting information on voltage, various fault currents, wire sizes, components like breakers and fuses, overcurrent protective devices, and they'll work their way through the primary, secondary, the bus system, everything from A to Z. At that point, we move into the short circuit study. It's going to verify the protective devices and electrical equipment components have the adequate interrupting capabilities. They'll get into equipment parameters like voltage, impedance, power rating. They'll look at all the fault scenarios. They're going to run calculations of short circuit currents for different fault types. They'll do analysis of the protective devices and those fault types, phase to phase, phase to ground, 3-phase, different types of asymmetrical faults, and make recommendations. You get into coordination study, it's going to verify the adequacy of the protective device settings and proper coordination to isolate the faults. So it's going to look at the overcurrent protective device and make sure they will operate in the specified time limits in order to clear the fault. They're going to look at relay coordination, design assessments, checking of the settings on these particular overcurrent protective devices, looking at fault clearing times. There's things such as time current characteristic review and those types of plots. They'll look at transformer protection, fuses or breakers to protect the transformers and cables from faults. We get into the arc flash study. That's going to determine the PPE requirements to operate and maintain your energized equipment. It'll also include the one-line diagram. This is where the calculations occur for the arc fault current and your incident energy. It'll help to derive your arc flash boundaries. It's going to get into the power system data, and the studies will compile all this information to be able to produce labels, which is critical for companies to protect their workers, their vendors, anyone working on the electrical equipment to protect themselves and to lower the risk of shock, arc flash, and arc blast to an acceptable level. One of the things also in these studies, you can potentially identify means and mitigating operations to either eliminate or reduce those energies to a more acceptable level. You might have a significant incident energy that might be able to be reduced with the expertise of these arc flash engineers. So they're a phenomenal group of engineers that have years and years of expert OTJ type training, because it's not something that you will learn in your electrical engineering curriculum coming out of college. So they pick that up in their field operations work. Next slide. This slide, just one of the underestimated elements of these studies is getting a single line up-to-date drawing generated. The ARC Flash engineers will compile in their field assessments a configuration of the electrical system. And it's required under the standards of NFPA 70 and 70E. You want to have a clear, concise, and efficient, very thorough single-line diagram. It'll compile all the power sources, your utility grid and generators. It'll get into the distribution elements. So it's kind of flowing like a tree, and you work your way down the distribution through the bus, which is your horizontal segments and your branches coming off of your bus. You'll then pick up different electrical assets, your transformers, all your protective devices, such as your circuit breakers, fuses, and overcurrent protective devices. You'll pick up loads for your motors, your lighting fixtures, other equipment, other important aspects. You got to have that legend, which should clearly state what the symbols are and what they are for the various electrical maintenance people working on it. There will be voltage and current information, and as well as a good layout of the electrical system. So it's definitely underscored and critically important. So when you change or add or modify your electrical systems, you need to go back and update these diagrams. They're crucial for troubleshooting, for your record keeping, for all kinds of safety and facilities maintenance.
No, we'll get to the benefits.
Okay. So many different benefits. We could spend a whole session on the benefits here of the Arc Flash. It's such a comprehensive service. But if we break them down quickly in the interest of time, worker safety is significantly enhanced. Things that are mostly key is identifying those potential dangers, developing safety measures, getting into the knowing the levels of your incident energies will help you to develop PPE strategies and identify potential arc flash hazards that might be unknown due to these changes in operations or damaged or deteriorated equipment. Compliance with the standards is another critical element. We can get into those standards in another session. Facilities, electrical equipment, overcurrent protective devices, looking at those fault currents, checking the proper coordination, ensuring that everything is properly sized, can handle the faults, will perform as required or designed. And then we have looking into preventive maintenance guidance to pinpoint target hazards, optimization of your systems in terms of hazards and mitigating those overcurrent protective device problems. You might be able to adjust them or reconfigure. Emergency preparedness comes into play, because by identifying these hazards, you're going to be able to develop approaches for safety measures. Improving your training and awareness are key to the safety of your employees and education. And then the big piece not mentioned is the cost savings. Huge cost savings in all areas by conducting these surveys.
Yeah, and then again, we'll get to the fun stuff, which is some case studies. Can you go through the case studies you prepared?
Sure. Yep. So case study number one is a classic situation where you have an older power panel, and you may have a need for adding a breaker to it, and the breaker might be added by a qualified electrician, and it might physically fit, but it doesn't have the appropriate electrical engineering adequate interrupting rating, so it gets thrown in there over time, and maybe it wasn't designed as originally intended. The fault current isn't properly sized, and you've got a situation where this could lead to it not performing as designed, and that would potentially cause it to not clear, and you'd have a fault incident that might go further upstream at a higher, or downstream at a higher level, to result in a more catastrophic incident. So a mismatch breaker. In this case, you've got a coordination study situation where you are detailing situation where you'll have overlapping of the coordination. It's a different type of a molded circuit case breaker, and the breaker settings may have been changed to avoid a tripping situation. It will prevent one breaker from tripping if a fault was to occur on the downstream of the secondary breaker. So making sure that everything is coordinated and properly set so that it performs as designed is another key component of the arc flash study.
Great. Thank you, Jeff. And let's go to Lee here. What is the return on investment? I'm sorry. Can you explain how you implement arc flash analysis at your facility and how it's been helpful?
Yeah, happy to, Jared. At RPM's operating company facilities, the implementation of the arc flash analysis program is three-pronged. One, we want to make sure we conduct that initial arc flash study upon commissioning of new or recently expanded operations. In the last 12 months, we've had 6 new facilities added to our portfolio globally. So getting those arc flash studies commenced is key. Number 2, conduct that initial arc flash study of a newly acquired operation or facility. So historically, RPM's growth has been through acquisitions, and we've got to make sure that those newly acquired facilities that come along with a product or a trade acquisition also have the same level of safety, electrical safety implemented that the rest of our sites do. So doing that arc flash study initially there is key. And then third, it's conducting the 5-year revalidation studies, which captures any changes to our electrical distribution systems that may have occurred during that time period through growth or process changes at the sites.
Great. And then, Craig, same question to you.
Yeah, certainly, Jared. So this is a collaborative process overseen between our environment, health, and safety team and the local operations team. The global EH&S team is going to set the enterprise-wide standards, and then the local environment, health, and safety team with the operation teams are going to implement that around the world. It helps us improve and ensure worker safety. We can identify the proper PPE that's necessary to do various functions. As mentioned before, it helps us achieve compliance. There's a definite upside from a preventative maintenance standpoint. We do training and awareness for all the employees that are involved in this. And then if an emergency were to happen, we have the plans and procedures in place to ensure that our employees can work on this equipment if it's safe to do so anywhere around the world.
Great. Thanks so much. And I know we're running up on time here, but we have a couple more quick questions for me, and then we're going to get to the audience questions. So get your questions in. We'd love to hear from you. Let's ask Jeff here quickly. Why is it best to bundle these things together, infrared, arc flash analysis, and electrical safety training? And I know that's sort of what we're doing as an organization, right? To create a bit of a division in our organization. Hey, we're doing just this.
Yeah, absolutely, Jared. Indeed, it's a matter of cohesion and a uniformity. The services all go hand in hand. One impacts the other in both directions. So having a good quality 3-pronged approach here with the electrical safety training, arc flash, and infrared is key to the success and performance and safety of companies' electrical systems and the integrity of their operations. So starting off with electrical safety training, following the standards, working on energized electrical equipment. It's crucial that any individual workers achieve that qualified versus unqualified status, whether it's just performing repairs and troubleshooting as an electrician to performing any of these studies. Understanding the hazards and the arc flash dangers, implementing safe work procedures and practices, making sure you have the right PPE, interpreting your results. Getting into the arc flash study, it provides a crucial aspect to high target and high risk components, getting your calculations and assessments done to make sure everything is functioning as designed, getting your boundaries together. It has a key element in your overall safety It's crucial for the infrared surveys because now you know which panels are safe to open and provides that guidance for the covers to be safely removed. We talked about that earlier in the presentation. So some covers aren't going to be removed if there's too high an arc flash incident, or the risk assessment shows that it's not safe to do so. So the infrared study relies heavily on that. Vice versa, the infrared study can provide good guidance for the arc flash study as well, but that infrared study will then, target those abnormal temperatures. It'll early detect and pinpoint hazards. It'll help improve the accuracy of the assessments, and it will give you targeted assets to make sure you have the right risks identified and safety training for. So it's going to identify potentially those items and assets that will be more likely to fail than others based on temperature and other conditions.
Great. We're gonna get to one last question, then we'll get to the audience. What is the ROI on risk engineering? Lee, what's your thought on that?
Yeah, thanks, Jared. Although the investment for RPM across our nearly 400 operational facilities is over $500,000 per year, the payoff is truly the cost avoidance. And not just the financial cost, but the potential cost of employee exposure or injury or worse, which we can't put a value on. And in addition to that, the avoidance of millions of dollars of expense from potential catastrophic loss of facilities, the equipment, and then the business interruption that comes along with that due to those electrical system failures and hazards that we're avoiding through putting together a solid IR scan program.
Sure. And Craig, what do you think about return on investment?
Yeah, so very similar to Lee, the ROI is extremely high compared to an employee injury or the shutdown of any of our manufacturing facilities. Global Products, which is an external reporting segment of JCI, did about 9.5 billion in revenue during our last fiscal year. The output from these IR surveys can be instantaneous, and it gives actionable pictures and recommendations to our local operations team so they can address or make the corrective action in the short term, thereby reducing the potential for downside at our facilities.
Great. I'm going to jump right over, in the interest of time, right to the Q&A. Here comes one that we got a little while back. Does infrared thermography have the potential to be used to discover hot spots in grain elevators or feed mills, specifically DDGS? Jeff, I'm guessing that one's for you.
Okay. Yeah. Well, we can detect all kinds of anomalies in grain elevators and feed mills, from motors and bearings to all your standard electrical components. In the elevator legs, there's potential for friction and heat generation. You've got a lot of contaminants, with airborne dust. And so you're going to have wear and tear. Indeed, we're going to have a bunch of unusual aspects to consider: high ambience, different temperature gradients, different locations, and unusual operations happening. So high amperage demands. So there's all kinds of favorable predictive strategies to uncover in an elevator and a grain handling facility. And of course, within federal OSHA, it's one of those target operations for making sure you have all the right electrical predictive and preventive maintenance programs in check.
Here's another question. This comes from Chris. Getting AF compliant is one thing, staying compliant is another. What is your recommendation on how to remain compliant? Also, should a plant or company have an EE on staff or someone trained on AF calculations to support an AF program? If you want, Jeff, I can put that in the chat for us so you can take a quick peek.
Yeah, I think there's a lot going on there. It's an excellent question. As I mentioned earlier, electrical engineering curriculum, there isn't specific subject matter that's coming out of there. So these arc flash engineers are gathering this information and becoming developing their expertise through years of training on the job compiling these studies. So it would be difficult. Most electrical engineers at plant level would not have the expertise to be able to undergo the studies elements. Larger facilities are more complex that have people that maybe were working in a prior life might be able to favorably impact. So having one on staff would certainly be ideal, but it may not be possible. And then maintaining compliance is crucial. Trying to develop that is difficult. You have to initially get that baseline study done by a qualified expert, whether it's in-house. You have to be very specific because there are elements of NFPA 70E that are required to be followed. And then there's IEEE 1584. So one of those standards, the 70E, is going to deal with the shock and electrical protection elements. And the IEEE 1584 is going to get into the actual calculation methods and the formulas. There's software that gets involved, things like SKM and others. And these studies will generate hundreds of pages of code, and formulas and these complex time current curves. So it takes a high degree of expertise to be able to produce these to stay current. So an initial baseline by a qualified expert, you're talking a significant liability. So these people are maintaining their PE licenses, and there are different regulations within different states. There are 6 particular states that have different more exhaustive types of considerations for the PE. So there's a whole host of different things that go into play there. Then you have your 5-year revalidation studies. Lee was mentioning that, and I think and Craig. So all companies have that. When you change or modify, you have to there are various triggers within the cycle between your initial and then the next 5-year. So there are trigger points that will cause a revalidation that might be sooner. So you have to, consider and factor into those sorts of things. So there's a lot of different things going on. And if need be, we can post this question to our internal Arc Flash engineering experts and put out something. I'm currently working on something with them right now. The triggers for the studies, when is it required, sort of a thing. So it's an excellent question, and hopefully that gives a good starting point.
Sure, thank you. If we have time, there's one more question. I just want to make sure everybody gets their questions answered. I know we're sort of over the hour.
We got 2 minutes. We can wrap it up with this one, though. That'd be great.
Sure. So this question here is: some jurisdictions do not allow opening live HV, MV equipment for IR. Installing IR windows may compromise integrity of doors, or they may not have the wide view to make IR valuable. I can put it in the chat there, Jeff.
That's a good one. Yeah, we encounter that one frequently. And it's a difficult question because there's so many aspects that have to be considered, right? The person does bring up the potential for, I've now modified the switchboard, right? So am I liable now if there's a failure because we've cut into the panel? So there's all kinds of different papers out on IR windows. They are extremely beneficial. Overall, they're very extremely beneficial. You'll have a certain number of years of where that panel will have its warranty. And that's what I think the individual is pointing towards is, do I void my warranty on my equipment? At some point, you can't just ignore the potential exposures with a higher incident energy. So when he says medium voltage and high voltage, medium starts at 1,000 volts and up. When you have a high incident energy, you're not going to be able to safely open it. So what are your options? Your options are, I'm not going to be able to do IR scan on it. So I can do airborne ultrasound on it. It's great, but it's not going to necessarily pick up certain things that thermography will, and vice versa. The two are going to be used hand in hand. You can do visual inspections on it when you do a shutdown. All right, that's great, but you're still not going to know. You could use potential thermochromic devices where you have temperature heat rated stickers and things of that nature that you could place on the gear during a shutdown, and then you could inspect that when you go through the next shutdown. But what happens 12 months later? You have a fault and a failure in there. So having these IR windows are fantastic devices. You've got to design them appropriately, though. He's exactly right. He's talking about different elements where you have interstitial spaces. So one 4-inch window isn't going to cover it. A 3-inch window is going to cover it. You might need 12 of them, strategically positioned on the side, the front, the back, in the right position. And then you still got to wear your PPE. And then you have to account for the transmissive qualities, because you're going to lose transmission through that window. So if you just try to take the actual temperature measurement without adjusting your camera, you've got factors there. So a lot of different things that go into the proper selection design. There are 3 or 4 or 5 or even more major manufacturer of those equipment. Work directly with them. I know the CEOs of several of the top ones. They've spent years of developing, and the technology has improved dramatically. So it's an excellent opportunity. We found tons of things around the world through those infrared windows, but be cautious about them. You can't just blindly accept them. You have to make sure you understand their limitations. Excellent question.
Great. Thank you, Jeff. And thank you to our panelists, Lee, Craig, Jeff, and I'm just going to send it back to Justin from RIMS for a final word.
All right, that was great. Special thanks to Jeff Freilich, Craig Bartol, and Lee Bowers, and of course, Jared Shelley of GRC for their time and expertise. The GRC team has your questions and will reply to you directly if we didn't address yours today, but I think we got them all. A copy of this webinar will be archived on rims.org within a few business days. There are lots of resources for you to access. You can find them at tuvesud.com/GRC. That's on your screen right now. You can also check out GRC through their LinkedIn page. They're fantastic. The next webinar collaboration between RIMS and GRC will be in 2025, so be sure to visit rims.org/webinars for more information. And a quick plug for Risk World 2025. Public registration is open. Join us in Chicago, May 4th through the 7th. Register today at rims.org/riskworld. This was a wonderful session. I'd like to thank you all, and stay safe.